Okay, so we are going to do an intro to three-dimensional or 3D solids. Okay, so by definition of 3D solids, it's a three-dimensional figure. We also have the definition of polyhedron. I'm going to define here in a minute, and the definition of prism. So the definition of a polyhedron, it is a solid formed by polygons. If we do a quick review of polygons, a polygon is an enclosed figure made up of segments. So I can make it as weird as I want, but all the sides are made of segments. Definition of prism, it is a polyhedron with two congruent bases that lie in parallel planes. Okay, so an example of a prism might be a rectangular prism. And why are these dotted? Okay, so you need to understand that the reason why they're dotted is because they are edges that are there, but you cannot see them. So this is a prism because it's a polyhedron. So all the sides are polygons. So this is a rectangle, 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 or even a parallelogram. We don't really have that information. We have two congruent bases. So that means that this top is the same exact size and shape as that bottom. We could also have a triangular prism. Hard to do this when I'm not on the dry erase board. Okay, so in this one, though, the bases are the two congruent shapes. So typically we think of what's sitting on its base. In a triangular prism, in this situation, this is a base and this is a base. So you're looking for the two congruent sides. You can also have a pentagonal polyhedron, so you're looking for the pentagonal, obviously, as the base of a pentagon. So the name of the prism goes by the shape of the base. This is a triangular prism. So the base is a triangle. This is a rectangular prism. Now, typically in a rectangular prism, because, well, this top is congruent to this bottom, this front, if you will, is congruent to the back, and this side is congruent to this side. So, depending on where it is, in a rectangular prism, we assume, I know what that word means, but in a rectangular prism, we assume it's sitting on its base. Okay, so we make that assumption. There's some other solids that we need to discuss, and that would be a cylinder. So a cylinder would be like a pop can or a can of soup. So when you draw those, and I'm going to try to draw them, typically I have my dry erase so I can cheat. Okay, so we have a cylinder, we have a cone, we have a sphere, be like a basketball. We have also a pyramid. Move this up a little bit. Now a pyramid, it just depends. The definition of a pyramid is a polyhedron. With one base. But it doesn't tell you what shape this base has to be. So this base could be, and I'm not going to use my dotted lines because it's kind of hard to do these. You could have a square base. And again, these should actually be dotted. It's kind of hard to do it right now. You could have a triangular pyramid. Again, these should be dotted. Okay, so your pyramid can have a different base. It just means that you have a base and then all of your sides go up to a point. Okay, so we could continue this with other pentagon and hexagon shapes as well. We also have a cube. It is where all 6 faces are squares. Okay, so that would be an example of a cube. So you'd have to have all the edges would be the same. So I think of like a die. The die is one of a pair of dice. And I think we are going to stop there with the solids. Make sure I have covered everything. Prisms, cylinders, cones, spheres, and pyramids. I think I've covered everything.